There is a request for me to make a short video on the product of electrolysis of aqueous solution, so here's my little go at it. In electrolysis you've got a negative electrode and a positive electrode dipped into a solution of an ionic compound. The ionic compound would be something like sodium chloride, copper chloride, copper sulfate, silver nitrate, whatever it might be, an ionic compound dissolved in water. Those two electrodes are connected together through a circuit. You've got a power supply unit providing energy to that circuit, helping a chemical reaction take place. You have to decide what chemical reaction takes place, what happens at the negative electrode and what happens at the positive electrode. The negative electrode is, think of it as being full of electrons being pushed towards it. So this is going to react with things that go to it, positive ions that go to it, and it's going to reduce them. So reduction happens over there, always reduction at the negative electrode. The positive electrode will take away electrons from negatively charged things. So it's always oxidation that happens at the positive electrode. So you've got to decide what happens at each electrode. And what you've got to understand first of all is what's going on in an ionic solution. So I'm going to take sodium chloride as an example. If you put sodium chloride into water, sodium chloride is an ionic compound made of sodium ions and chloride ions that are held together in an ionic lattice. You dissolve it in water, those ions are no longer held together. They're surrounded by water and you end up with sodium ions freely flowing around the water and chloride ions freely flowing around the water. You also need to know that water is a substance which ever so slightly in a reversible reaction dissociates, breaks apart into hydrogen ions and hydroxide ions. You need to know the name of both those ions. There's tiny amounts of them in solution, but they're important in electrolysis. So it means that not only have you got sodium ions in solution and chloride ions in solution, you've also got hydrogen ions in solution and hydroxide ions in solution. And it's these charged things, these charged species, these charged ions that get involved in electrolysis, and they will travel to things that are oppositely charged to them. So sodium ions and hydrogen ions will move towards the negative electrode. You can see that if they're coloured. These aren't coloured, but you can see them if they are coloured. Negative ions like chloride and hydroxide will travel to the positive electrode, and again you can't see that unless they're coloured, but sometimes they are. Now when they get there, there's a choice of things that can happen. Either the sodium ions could be reduced to sodium atoms, or the hydrogen ions could be reduced to hydrogen atoms, which will then turn into hydrogen molecules, H2. So which of those gets reduced? Well, the answer is it's nearly always hydrogen that gets reduced. So if in doubt, guess hydrogen. But it's always the least reactive one that gets reduced. So if it's sodium present, or magnesium ions that are present, or lithium ions, or potassium ions, or most of the other ones that you're likely to come across, they're all more reactive than hydrogen. So it's hydrogen that gets reduced, gets turned into the element. Because reactive things hate being elements and love being ions. Hate being atoms and love being ions. Whereas hydrogen is quite unreactive compared to those. So it's quite happy to become hydrogen gas. So what happens is those hydrogen ions, two of them each gain an electron. Two hydrogen ions each gain an electron, so 2 electrons in total, and they become H2, the gas, and that will fizz like crazy. You'll see it fizzing like crazy, and you can test for it by doing the squeaky pop test. Lit, splint, squeaky pop, remember. There's one ion which is for an element which is less reactive than hydrogen that you might come across, which is copper. Copper is quite unreactive, and so copper gets reduced instead of the hydrogen, and the copper, I don't know why I've written it there, but the copper ions become copper atoms, and you form copper at the negative electrode if copper is present. That might also happen with other very unreactive elements. The only other one I think you're ever likely to come across is silver being reduced. So it's always going to be hydrogen at the negative electrode unless silver is present and will form silver. Silver ions are present and will form silver, or copper ions are present and they'll form copper. What about at the positive electrode. Again, you've got only a couple of choices to make here. So it's either the hydroxide gets oxidized, loses electrons to form oxygen, and oxygen will fizz like crazy, so you'll see it forming, or it's something else. Now the something else will be a halogen being formed from a halide. So the halogen will be something like Cl2, and for that you need two chloride ions to travel to the positive electrode, each give away an electron, and then you form two chlorine atoms that combine to form a chlorine molecule. And that will always happen if chloride is present, or if any other halide is present, like bromide or iodide. They will also convert to the halogen in exactly the same way. The explanation for that is beyond the scope of the course. Now, if there isn't a halide present, iodide, bromide or chloride, for example, if nitrate was there, or sulfate was there, or anything else for that matter, those can't be oxidized at the electrode. So instead what happens is the hydroxide is oxidized like here. Okay? So that's what I've sort of summarized there. I'll do a couple of examples for you. So if you had sodium chloride solution, first of all think, okay, what's going to go to the negative electrode? It's sodium chloride. It's always going to be the sodium ion and the hydrogen ion from water. And it's chloride, so it's chloride ions are going to be oxidized, or hydroxide that's oxidized. They go to the positive electrode though. Out of these two, hydrogen is the least reactive, so hydrogen ions that are going to be reduced with two electrons to form H2. And out of these two, whenever there's a halide present, the halide will be oxidized to give the halogen. What about another one? What about copper sulfate? So if we've got copper sulfate is CuSO4. Copper ions are 2+, sulfate ions are 2-. So we've got the two things that will go to the negative electrode are copper ions and hydrogen ions from the water. And the things that go to the positive electrode are the sulfate ions from the copper sulfate, or the hydroxide ions from the water. Here, the one that's the least reactive is the copper. The copper therefore would be reduced to form copper atoms, and you'd see them, you'd see the brown solid forming on the electrode, and the hydrogen stays in solution. At the positive electrode, sulfate and nitrate and all these other things simply can't be oxidized, so the hydroxide gets oxidized instead. And this is an equation you should learn, but you should certainly learn that oxygen is produced and learn the test for it. Little final detail. Have a little think here. If hydroxide is being removed from the solution, if you're taking hydroxide away, you actually make the solution acidic. So if you've got copper sulfate solution, the product, the solution, the water becomes slightly acidic because hydrogen ions will be left behind and hydroxide ions will be taken away from the water. So if you've got copper sulfate in solution, the hydroxide ions are lost, they're oxidized, and so the pH would go down because you've got more hydrogen ions left behind, making it acidic. Whereas with the other example, if you've got sodium chloride, the hydrogen ions are lost in the solution because hydrogen is less reactive. Remember, in the sodium, hydrogen ions are converted to H2. And if they're taken away and you've still got hydroxide ions staying behind, the solution becomes alkaline, or the pH goes up above 7. That's it. Hope that was useful.